So in this problem, we're given the task of designing a screw lift system that will be used in auto repair shops, shown below, and each screw lift will be required to support loads up to 20 kilonewtons. And we're asked to find the lead angle such that the system will be self-locking and find the maximum pitch that can be used to lift the 20 kilonewton load. So we're given the force that we're going to have is 20,000 newtons. We have the static coefficient of friction is equal to 0.1, which is the same as the coefficient of kinetic friction. And then we're given a diameter of 5 centimeters, and that gives us a radius of 0.025 meters when you convert it and divide by 2. And then we're given a torque of 60 Newton meters in part B when we're going to solve for part B. So we're going to split up in 2 parts. We have part A and B. A is going to be the lead angle. So to do that, we have our equation. We have our theta locking is equal to tangent, the inverse tangent of the coefficient of static friction. And we have that. This is theta locking is equal to the inverse tangent of 0.1, which gives us theta locking is equal to 5.7 degrees. So that's our answer for the first part of this problem. Now for the second part, we have our other equation, which is for part B, torque is equal to sine theta plus the coefficient of kinetic friction times cosine theta divided by cosine theta minus the static or the coefficient of kinetic friction times sine theta. And this is all multiplied by the loading force and the radius of the shaft. So we have the torque, the force, and the radius, and we're solving for theta. And we also have the coefficient of kinetic friction. So we're going to plug those in, which is 60 is equal to sine theta plus 0.1 cosine theta divided by cosine theta minus 0.1 sine theta times 20,000 newtons times 0.025 meters. So we can divide both sides by 20,000 times 0.025, and that leaves us with 0.012, or 0.12 is equal to sine theta plus 0.1 cosine theta divided by cosine theta minus 0.1 sine theta. And then we can multiply both sides by the denominator of this fraction, which gives us 0.12 cosine theta minus 0.012 sine theta is equal to sine theta plus 0.1 cosine theta. And then we can combine our like terms, which would be the sines and the cosines. So when we do that, we get 0.02 cosine theta is equal to 1.012 sine theta. And from here we can use some trig identities. We know that sine theta over cosine theta is equal to tangent of theta. And when we use these values that are lined up with the cosine and the sine, that comes out to 0.02 over 1.012. And so now we're going to solve for theta, which to do that we just take tangent, the inverse tangent of 0.02 over 1.012, and this is going to be our theta, and we get that theta is equal to 1.132 degrees, and that is our solution for part B.